All right, so today is June 14th, so I've planned out my entire project. Well, maybe not the entire project, but at least the foreseeable project. And I'm just going to follow it step by step, and hopefully I'll get somewhere relatively quickly. I'll give myself an hour, so at 9:30 I'll stop. So first, we got to create a class object to store all the input coordinates. So this one, first let's just make oh, not Jupyter Notebook. Let's call it function. All right. All coordinate information for. All right. So if this contains all the coordinates within each, let's see. So the attributes I should have. First of all, okay, I'm going to make my initiator first. I think I'll just make an like I won't have anything here. Creates a function object with all default attributes set to nothing. Because I think it'd be too complicated to make a function that's defined through coordinates first. So I think I'll just make like a blank slate, and then probably I'll have like something else that just adds every coordinate in, right? I guess what we can do is take a range. So I guess this would be domain. Which is just should be a tuple, right? Domain would be tuple. Because it's just tuple containing A, and B, referring to the start of the domain and end. So this will be all for a function some finite interval. Because obviously I can't have infinity as a domain. And for the purpose of this project, I'm not trying to make the Fourier transform. I think that's a little out of my league. Just because I've never taken any math course beyond first year. So I'll stick with some finite interval, and I think that should be fine, actually. So we have the domain, and then we have, I guess, coordinates. So there should be a dictionary containing keys of values between A to B and corresponding values of f at. And here we should have should be what? Float. Yeah. So then a domain equals self.domain equals domain. This is not confusing at all. And then self.coordinates equals just an empty dictionary for now. Actually, I'll just have this be A float and then B float, and then I'll have domain be A B. Preconditions will be A B is greater than A, or greater equal to, greater than. Yeah, greater than. I don't want to deal with a single point function. Because this function is not supposed to be like a very general one. Like, it's not supposed to work for like all of mathematics. This is just for the project itself, right? So I'm thinking a bit of shortcuts. Then I should have a add. I'll just call it add. Between A and B. Corresponding values of f of x. Okay, no, that's fine. Okay, obviously precondition is that x is in between a and b. So first let's check let's see, if x is already in self-coordinates, this overrides it. So then it'll just be self.coordinates at x equals y. Pretty simple. Okay, great. And then I want to get, and then I guess x, which would be a float. Because my concern is if we have a value at like pi, right? But I want, and then like a value at e in pi, but I want the value at 3. I want it to be able to get the average, right? But it should be a weighted average. So I mean, if x in self.coordinates dot keys, then return self.coordinates of x, obviously. Okay, this returns a float. Alright, otherwise, we gotta find the lowest key. Or I guess I'll just do yeah, I'll just return 0 if the coordinates are empty. I don't want to throw an error because that's kind of like a, yeah, I don't really want that. No. For input in function defined. To be fair, this is assuming the function is defined at the endpoint. I don't know if this is a. Or actually, you know what? I'll do like this. Function defined minimum. Right. I'll keep the bigger equal to, but function and variable and function should be lowercase. Alright, fine. Alright, now we want to make I need to interpolate the value in between. So I need to make a function. So m is equal to fm max minus fm min divided by max minus min. Oh, plus max minus min, yeah. I wonder if I can even do this notation. If that notation would be really useful, actually. If I can just do like, hold on. Help me out, bro. Oh, you can. Great. Alright, that's amazing. Awesome. Okay, so we can call this instead call. Yeah, that's fine. Okay, let's see. So I have our slope. Y is equal to mx plus b. I have to solve for b as well, and then I can plug it in. There's gotta be an easier way, is there? Probably not, actually. Okay. And then b is equal to fat max minus self maximum minimum. This is even defined recursively a little bit. Minimum times the slope, and then we return m times x plus b. Let's have a few dot tests based on the linear approximation between the closest two keys, 0 and 4. F dot add 0, 5. These should automatically convert to floats, yeah? I hope so. And then if I want f at 1, this should return 10. And same with f at 1.5, this should return 12.5. let's see if this works. No. Solve the coordinates. Okay, let me just parse into a float then. FL1 didn't work. Divide by 0. Since 1 is maximum minus minimum. Huh. Is that the case? Alright, well, let's not waste time. Let me just debug it. Minimum. Maximum, this should be 2. Yep. Great. Now for each input. Input 0, input's obviously bigger, something. I see. Precondition self is defined for at least 2 values. That's kind of stupid. Wait, hold on. What am I doing here? Alright, if self.coordinates dot length. How do I get this as length of? Okay, wait. Okay, here. If function the length of function self at what? I thought this was a list. I guess not. Okay. That's fine. I just want the item. Okay, let me. Okay, hold on. Strict keys Python class. Oh, okay. So I can just list it. Okay. List function define. Or otherwise, our minimum is this, maximum is this, and then for I in range of length is less than minimum, or minimum is greater than input function. Well, list. Let me think. So as soon as the minimum is bigger, then what we want to do is set maximum to this and minimum to this. Break. Does this make sense for lists of 2? Or sorry, this should be X, not minimum. And it should be the other way around, huh? Okay, this should work. I think so, at least. Oh, let's go. Look at that. 4. Since the slope is 5, yeah? Then we should get... also, wait, okay, no, hold on. Let me finish this. 5. So this should be 20, right? 5. 2 is 15. 25. I can't even do math. No. Great. Alright, that works perfectly. I just realized for add, I can do set item. Set item. Yeah. So here I can do f at 2 equals 15. Perfect. Alright, this is good. This is good. This is a very good notation. I like this. I think this is all I need, actually. Is there anything else I need? Inputs. Hold on. Creates class object historical input coordinates. I did that, right? Great. Okay, now I can move on to our main, I think. Create a function that inputs the coordinate collection objects. Okay, so we input the function, and some sinusoidal function, okay, and outputs the integral of the product over 0 and 1. So this is just our main, then I'll call it Fourier. Alright, great. Alright. So we need to create a function that inputs the coordinate collection object, outputs the integral of their product. Okay, I'll call this Fourier interval, and I'll input one thing that's f. So this is the function. See, I'm not sure how to add in a different function. My idea is, like right now, it's my idea. Since we know the Fourier basis is just 1, and then sine 2 pi x, cos 2 pi x, sine 4 pi x, cos 4 pi x. Yeah, I can do it by index, right? But when we generalize to a and b, the interval ab, I'm not sure if that will still work. It should be fine. Call this Fourier interval. I'll just call it product interval. X, g at x, dx. Is mapped to 1. 1 is mapped to sin 2 pi x. 2 is mapped. And this should be pretty easy to code. Yeah, okay. And then precondition. I don't think there is any precondition, right? I'll just do a precondition of a is less than b, though that doesn't have to be the case. It doesn't really matter, but just to keep things simple, because the way I'm going to compute this integral is going to be like that. So let's cut our integral into 50 pieces. So let's make a division of 50 pieces between a and b. I guess, okay, increment. Increment is equal to b minus, is it? Let's see. So I have b minus a over b plus a. That doesn't seem right. 50. What am I doing? Okay, hold on. In 50 increments divided by b plus a. Or no, this is no, b minus a over 50. And okay, that'll return the increment I need to go at. Okay, so while so then index is equal to a. So while index is less than or equal to b, using a using a midpoint Riemann sum. I guess I could do trapezoid, but I think that's a little I think midpoint Riemann sum is probably the easiest. Because this ensures there's always one more point after it. Okay, let's think. So our y is equal to f at a times g at a. You know what? This is my solution. You know what? Never mind. This is my solution. My solution is actually pretty good, actually. I'm gonna define g as a function, right? And I'll have a define function, and this will return a function, and returns. Okay, this will take an index, which is an int. Returns a function of the ith member of the Fourier basis. So that is 0 is 1, 1 is sin 2 pi x, 2 is cos 2 pi x, etc., etc., dot dot dot. So with this, then Let me just, my computer is not liking me right now. Shut some things off. There we go. That should be a bit better. Okay, so this is the precondition. It's greater or equal to 0. How do I... Okay, so if I equals 0, equals 0. What am I doing? Then f is equal to function define on AB. Function AB, right? Maybe not callable, bro. What? Why is this so weird? Wait, why can't I... Okay, I'll just keep on going. Everything in the middle is inferred, so that's great. Else, if... Okay, so let's see. Every odd is a sin. Every even is a cos. So if I mod 2 is equal to 1, right? Then this is sin, else this is cos. Okay, so if it's 1, 3, okay, so I plus equals 1, I divided by equals 2. Okay, now I need to make between A and B. How many points do I want? Let's say 100 points. I want 100 points. So increment is equal to B minus A divided by 100, right? Index is equal to A, while A is less than, or while index is less than B. I want you to set f at index is equal to, how to use trig functions Python. Math, import math. Okay, that works. And it's in radians. That should be fine, right? Okay, let me import math as well. I really don't know what to do with you. I use your initializer. I made the initializer. Oh, that's okay. Sure. Okay, f at index is equal to math sin of 2 times I times pi math.pi times index. And this should be the... Okay. I see. Okay, hold on. F. Okay. And then at the end of all of this, I'll return F. Oh, and then here, index plus equals increment. And then this is basically the same thing. It's 2 to the power of... yeah. Okay, function. Returns a function. Relax, bro. Unresolved, bro. Fine. I'll leave like this. No one's unhappy like this aside from me. That's fine. So we divide I by 2, and then we do the exact same thing, except we do math.cos. Let me just make sure. I don't really trust BedMass, so I'm gonna put it in myself. Okay. This should be fine. Define Fourier function. I'll be more specific. Okay. So then, okay, if I define G is equal, define Fourier function, let's say 0 from 1 to 10, 0 to 10. Right, if I want G at 4, I should get 1. 1.0, that is. If I want G at 10, I should get 1. Okay, now let's define F is defined for your function. Say 3. 0 to 10 as well. So let's get F at math.pi. Let's just say 3.14. This should be 0. Though it might be very close to 0, so in that case, less than 0.01, it should be true. Let's say 0.1. It should be pretty accurate. Like it's gotta be pretty accurate. Wait, so what is 3 exactly? 0, 1, 2, 3. It should be sin 4 pi x. Okay, sin 4 pi x. Sin 4 pi x. Give me... So this is f at x, yeah? Give me f at 0. Oh, right, 4 pi x. Okay, sorry. Then this should be... Yeah, any integer should be less than... Okay. What about, like, 1.3? F at 1.3 should be... Oh, minus... I guess plus 0.5 87785 252 should be less than 0.1, and this should be true. Okay, yeah. Let's see if oh, it worked. Look at that. Oh, beautiful. Beautiful. Okay, this is awesome. Awesome. Okay, now I can actually do my integral function. Let's see. So we have our 50 increment, of course. So y is equal to f at index times g at index. This is the y. This is how tall it is. And the width is increment. Okay, so we have our sum. Oh, is it index? No, I'm doing a midpoint Riemann sum. So index plus increment over 2. Okay, I'm just going left Riemann sum. Come on, that's fine. Wait, is this a left Riemann sum? Wait, left first right Riemann sum. I just want to make sure I'm doing this right. Left, I believe, is. Never mind, I'm doing a right Riemann sum. That's my bad. Using a right Riemann sum. Actually, I'll do a midpoint. It's fine. What am I being lazy for? Midpoint. Index plus increment divided by 2. Plus equals y times increment. I believe that's correct. I believe that's correct. And then we return sum. This will return a float. I believe that's it, eh? Integral sum. Let me think if there's anything missing. Should be. That's actually shockingly simple. Let's test it out. Okay. Let's do the function. Alright, sin 2 pi x first. Right. So this is in the Fourier base, it should be first one. And so I want to take the integral from 0 to 3 of f at x, g at x, dx. Okay. Okay. So eventually, okay, let's define our functions. 0 to, let's just say 4. I'll say 3. And then I'll say f at 0 is equal to 0. Right, and then f at 3 is equal to, this is 2x, right? 6. Okay, so this is a well-defined function now because it's just linear anyway. I don't really care about anything else. G at G is equal to define Fourier function. This is the first one from 0 to 3. And then I want to do product interval then I have f, I have g, and then I have 0 and I have 3 minus or plus 0.95493. This should be less than 0.001, and this should be true. Oh, crap, I got an infinite loop index plus equal increment. That's my bad. I got false. What if, is that just because it's not accurate enough? Let's make it 0.1. Still false? What? I'm not entirely sure. Okay. Well, either way, I'll take a look at this next time. This was a pretty good first day. I did a lot, actually. In fact, on this checklist, I have none of them. Great. Okay. No, I have nothing checkpoints on. That's still probably gonna be. That's probably gonna be tomorrow, to be fair. Okay. Never mind. But I'll add that to my blog. Yeah. So that was first day. Spent about an hour on it, maybe a little over an hour. I'll have to take a look at this next time I do this. Probably tomorrow or something. So I was looking at this, and then I realized it's a very stupid mistake. But yeah, I can see the mistake now. Index plus increment divided by 2. Before, it was like this. And so I'm taking the average between the increment and the index, which is completely wrong. And this still worked with the very first number when I was debugging it because, well, it's the first one, right? But no, it makes a lot more sense that I have to, divide it by 2 after, but just for the increment. Otherwise, it's not going to work. And yeah, it works like a charm now. Now I run the test, my product interval is correct, and boom, the tests are passed. So, yeah, I'm a little stupid, but now the whole function works, and it's great. And yeah, this is a very good point to be. Now I can do a lot more tomorrow or whatever next I do this project.